It's recording now. Let's see. Right now, you should be able to look at my slides, right?
Yes, Doctor.
Okay, great. Now, have you tried out this activity, 4.7? Any of you? Okay, I'm going to provide the solution. You try it out first. I'm going to provide this solution at the end of this chapter, which I believe it could be today. Oh, no. I think let's just finish it on next Monday. So I'm going to share all slides with this solution. You may check, okay, when you have tried, check your answer and compare it with mine. Now, bear in mind, my answer not necessarily correct, okay. Let me know if you found any mistake in my solution, all right. Now, another thing would be there's probably some differences in our answer slightly, but I don't think so is going to have different more than 100 meter. No. Now, why is there differences? Look at this, all right. If you are using the same decimal point or same significant number, all right, then our answer would be the same. However, if we are using, slightly different decimal or even significant numbers, then our answer we're bound to have difference, all right, but it's not going to have large differences, all right. For example, in this case, right, you have 12.6 kilometers. Well, 12 kilometers is quite a long distance. The difference is kind of small if in terms of 100 meter, it's kind of, that means 0.1 kilometer lah, all right. It's very small, all right. It's less than 10% lah difference, okay. Okay then. Now you try this out, right? Now I believe some of this question, right, might be repeated using the other two methods. All right. This is direct integration. You have the next one. You are going to have numerical integration, and then you are going to have direct step method. So next method, the method that we are going to look at today would be the numerical integration, which is this one here. Now, let's look at this. You guys are looking at the table right now, right? The numerical integration formula. Am I right, guys? Yes,
Yes,
all right.
Doctor.
Okay, great. Now, look at this. This table actually have 4 sets of equation. Here on this slide, we have three sets of equation, and the next slide there's another one. Now, what is the difference between this slide? Now, the first equation, the first set of equation, it says it applies to all sections, channel sections. That means, regardless of whether it is rectangular, trapezoidal, triangular, circular, okay, or a segment of, circular, you can use this formula. Now, what is the difference between left and right formula? You have once in the middle, right? You have dy over dx equal to the term which consists of this conveyance as well as the critical flow formula, right? Now, look at this, all right? The subject of this equation is dy over dx. So I move dy to the other side. So I kind of switch, I have this inverse of the whole formula. So I make dx as the subject of the equation. Now, earlier, all right, in earlier classes, I've told you that in our syllabus, right, we will be focusing to find L instead of, dy. In our class, right, dy, the differences either is known, all right, either it is straight away given, directly given, or you are going to find it lah. For example, if they ask you to find critical flow and depth of uniform flow, right, you are going to find the difference and you are going to get the difference in y and things like that, right? Now, I'm sorry, too many distraction, people keep joining in. Now, dx, what is dx? Dx would be the difference. Let's look at one diagram here. Now, here's the thing. If I said, for example, I have y naught, yc, all right? Either it is the question have already given y naught and yc, or we can actually find the value of y naught, yc, of course, given the flow characteristics, right? We can find them. Our purpose or our objective is to find L, all right? Okay, too many people joining me. Okay, now, our purpose is to find L. But, as I told you, all right, in our direct integration method, the steps that we are using is 1. That means n equals to 1. Capital N is a symbol for steps. All right. Okay, now, okay, all right. Now, for example, if I ask, even if the question inform you to use, certain number of steps, for example, 4 steps, right? What is the meaning of 4 steps? That means you are going to divide this between y naught and yc into 4 steps. Look at this. There is one part, 1, 2, 3 part between y naught and yc, all right? Okay. I think after 8:30 or 15 minutes, I'm not going to admit anyone anymore. All right. Okay. Now, we have these differences, right? Okay. Because it keep distracting my lecture. Okay. You have y naught and yc. And then if steps, that means, now what is the meaning of steps? All right, you have if the steps given is 4 steps, that means you are going to divide this gradually varied flow into 4 sections, all right, or 4 parts, all right. Now, how are you going to determine it? You are going to make dy constant. Now, how would you do that? What is the dy value? Dy value would be then y naught minus yc divided by 4. All right, let's look at this. Okay. I'm going to explain it using whole screen. Okay, by now you should be able to look at the blank paper, right?
Yes, Doctor.
Okay, great. Now, for example, right, in that case, right, I have flow, all right, coming down. I said, you know, the further up, the upstream is not affected, so thus it is still y naught. Then at this location here, when, you know, water flow into a pool or whatever depression we have here, this is yc. Now, we are going to determine, we are going to divide it into 4 steps. I don't know how the 4 step, you know, because we are trying to determine this distance here, dx. So this is just tentatively, I'm going to draw out one. This is the first part, second, third, and fourth part. All right, so n 4 lah, right? There are a total of 4 n's, all right, number of steps 4. Okay, so this is dx1, dx2, I have, all right, dx3, dx4. Those who are joining, just wait a second. Okay, let me finish explaining this. Okay, now 4 steps, right? dx1, dx2, dx3, dx4. Now our purpose is to find dx. Now this dy, right, how are we going to find this? Because I said this should be known, right? Okay. Okay, now this should be known. So how are we going to find this y here? We have y1, y2, y3, y4, y5. For example, y1, y2, y3, y4, y5, okay, y1 is equal to y naught. Okay, so I have y5 is equal to yc. All right, so what would be my y2, y3, and y4? All right, now we know that, all right, the reduction, all right, the decline of the depth of flow, I've told you that we are going to make it constant. Now, how are we going to make it constant? That means the reduction, okay, the decrease of depth would be in terms of dy. dy is y naught minus yc. That means the difference between this divided by, okay, so you are going to have first decrease, second, third, and fourth. So there are these 4, all right, decrease in depth of flow actually represents the 4 steps. That means there are 4 parts, all right. So for example, in this case, all right, we are going to have dy equals to a certain number lah, a certain value. Now, therefore, y2, all right, would be y1 minus dy. Okay, y3 would be, it should be y2 minus dy as well, or y1 minus 2 dy. All right, so y4 is y1 minus 3 dy. Now, you are going to get back yc if you have y1 minus 4 dy. All right, so the decrease in depth of flow would be constant. Now, our goal is to find dx, all right? Dx would be difference, all right? Different between all these parts. Now, this is an example of when the depth of flow reduces, okay? You also have cases, all right, where you have, you know, backwater flow, right? Okay, so this would increase. Now, just now, I minus dy. In this case, right, if you have y1 here and y2 here, all right, that means if you are going to divide, for example, n equals to 3, right, okay, n equals to 3. Later on, okay, you are going to find out that actually, you know, if you divide by 3, right, the dx, right, would not be equal, all right. Okay, so you have dx1, dx2, dx3. So this will be y2, y3, and this will be y4 lah, all right? Okay, so in this case, there are 3 parts, okay? So in this case, y2 is actually, okay, y1 plus dy. I hope you are clear, and y3 is actually, right, y1 plus 2 dy. Okay, now y, the original y2, or in this case this is y4 already, it should be y1 plus 3 dy, which will eventually give you the same answer as your y2 lah, the initial one. All right, so it comes back, all right, to that value. So that is, you know, when we ask you to find, to use certain steps. Now, in our previous topic, right, which we use the method of direct integration, we only have one steps, all right? The question didn't ask you to, you know, split it into few parts, all right? So n equals to 1, all right? Basically, in our, you know, previous examples of direct integration. Now, the purpose why we give you n equals to 1, remember that you have to do a lot of interpolation, right, to find the functions of u, n, and vj, right? So if we are going to, you know, ask you to split this, all right, to 2 or even more than 2, you are going to have, you know, spend a lot of time doing the integration. That's why we just, you know, for the sake of just understand, for you to understand how to use the direct integration, will just give you n equals to 1. Now, since the second and third method are much simpler, right, to solve, that's here we introduce you a certain n. In the question, we'll give you certain n. All right. So I hope you are clear on this. Okay. All right, then let's look at. Oops. Oh, I just closed the. Okay. So try this out. Remember, for I think this activity 4.7. I'll ask you to try this out. Now let's get back to this. Alright. Okay. Let's get back to this. Now, the first set of equation applies to all sections. Alright, as you know, which includes rectangular, trapezoidal, or even compound section. Now, the second set of equation applies only for rectangular because there's a simplification made. Alright, for example, look at the formula yc over y average, and of course the conveyance, which is k, right, k naught over k average. Now how do you find k average later? Okay, let me show you what is k naught and k average. Now, can I ask, maybe is Zaidatul there? Zaidatul?
Yes, yes, doctor.
Okay. Do you remember what is K? The conveyance? The formula? Do you remember what is the formula?
Wait, doctor.
Okay. Or even anyone can help Zaidatul, maybe Maizatul, okay? And I have Awati, and then, you know, Pasuntra. Right, Daniel. Who else? The names that I remember. Haris. Okay, now, okay, by definition, conveyance is the carrying capacity over longitudinal slope, right?
Yes, doctor.
Okay, so what is the formula then? Carrying capacity over longitudinal slope, right? Zaidatul, okay?
I'm okay, doctor.
Okay,
Yes,
right,
doctor.
okay.
Sorry.
Now, all right. Let's say, right, if the questions, okay, give us the Manning coefficient, all right? So therefore, this k equals to this, all right? This term, as well as it should be equal to this. Agree? Oh, sorry. I'm actually writing, but I didn't show it. Sorry. Equal to this guy. Agree or not?
Yes, doctor.
Okay.
Yes.
This is carrying capacity over longitudinal slope, therefore is equal to this. Now, of course, if you are using Chazy, it should be CAR to the power of half lah. Okay. Now, this is when it's using Manning. So if I want to find K naught would be Q over S naught, because typically Q is constant, S naught is constant. So which will give you uniform flow as well. Therefore, the conveyance is uniform as well, or the initial one. Now, how are we going to find average? K average, all right, would depend on 1 over n A average, all right, and R average. Now let's combine this. Okay, let's simplify this. Okay, I have 1 over n A, oh sorry, A to the power of 5 over 3, right? Okay, P over 2 over 3. So this is average, now average. Now, this formula, right, okay, would, alright, will depend on when you use the y average. Now, how are you going to find this y average? Okay, now let's look at our diagram here. Okay, I'll just draw it up here. Okay, for example, I have case like this. Okay, let's split into 3 parts. Okay, so n equals to 3. Okay, so my average should be, if this is y1, y2, for this section, okay, for this part here, my y average should be y1 plus y2, because I can find the conveyance, all right, for this part, which is this formula here, okay, over 2. My y average for this would be y2 plus y3 divided by 2. My y average for this part here would be y3 divided by, this one y2 plus y3 divided by 2, y3 plus, it could be y4 or yc, alright, plus divided by 2. That means half of this plus this, alright? So that would give me y average, alright? So far clear? Do you have any questions so far, guys?
No, doctor.
No, okay. Now, I hope by now, okay, you have this in your mind already, and this guy here, how are you going to get? We are going to do some, exercises for today. So we'll finish our class around 9:30 like that, right? Just one, and I'm going to, let's go through just one as activity, then we are done for the day, all right? Let's go slow, right? I'm not going to finish up the 2 methods today, just one method, which is numerical integration today, right? Okay, now, once you know that, okay, let's go back to our slide here. Now, for rectangular, okay, of course, YC, all right? For rectangular formula, YC you have, and then Y average. Now, how you are going to determine Y average, I have showed just now, but we are going to do exercise so that we could further understand how we are going to get Y average as well, okay? Now, K naught, K average, by now you should know the formula already, okay? Now, if the channel is very wide, okay, do you still remember for very wide channel, our hydraulic radius R is almost equal to Y, okay? Therefore, we use R equals to Y, right? So we can simplify. Look at this, the K, right, the conveyance, right? You kind of simplify it into Y naught over Y average already, okay? Due to the simplification for very wide channel. If we are using Chazy, okay, the numerator, the power is a power of 3. The denominator, okay, the power to the 3 as well. That means y naught over y average to the power of 3. Now let's look at when it is very wide channel but we are using Manning equation. Look at this. The difference would be the power of the denominator, where it is to the power of 10 over 3. That means 3.33 something lah. Alright. So that will be the difference, the slight difference. Okay. I hope you are clear. Okay. Now let's look at this activity. Now, the faster you help me solve this, the faster we are going to end our class today. Alright. Okay, let's look at this. Okay, let's do it slowly. Okay. So I'm going to minimize this guy here. Okay. You have this, okay, rectangular channel. So now I know I have a rectangular channel, okay, with 5 meter. Okay. Now, Manning roughness, N is 0.017. What else? Bed slope. S naught is 1 over 1000. That means it is 0.001. Okay. And then normal depth. Y naught is given, which is 1.45 meter. Okay. Discharge is 12.74 meter cube over second. Now, the normal depth reduces as much as 0.57585 at point B. Now, look at this, A and B. So, I'm going to draw this out. So, I have here is Y naught, okay? A is A here and then B here. Y naught is 1.545 meter. Now at B here, can anyone help me? What is the value of the depth at B here? What should be the value? Anyone? Awati? Are you there?
Yes, doctor.
Okay, what would be Y at B?
Is it 0.8715?
Yes, correct. How did you get it?
Sebab dalam soalan kata the normal that reduce as much as 0.5785. Jadi
Yes.
why not tolak dengan reduce tu?
Correct. Because it doesn't say reduce to 0.5785, right? It says
Yes.
reduce as much. Alright, good. Thank you, Aratif. So, Y, right, Y at B here, I put Y at B, alright, is 1.45 minus Y, minus 0.5785. So we are going to have 0.8715. Okay, so here is 0.8715 meter. So there's from 1.45 to is going to reduce to 0.8715, right? So there is a decrease in that. Now, what else? What are the information, right, that we are going to have here? That's it. Okay. Now the question says length of gradually varied flow. All right, using 4 steps. So N is 4 steps. Therefore, we are going to divide this into 4 parts. Okay, it says 4 steps here. Now, how are we going to divide this into 4 parts? Okay, so we are going to have dy, okay, equals to, all right, y in this case, we can put y1 minus y2 or difference in y or delta y, it doesn't matter. In this case, I'll just put like that, divided by 4. So I have 1.45, right, minus 0.8715. Now, actually, right, you know what? This is actually the value of 0.5785, right? Okay. Because this is a difference, okay, I just write it so that we know, right, how we are going to get it, right? So if you know, in exam, if you don't have time, right, you just write out this guy, I'm okay, all right, because it's actually the same value here. Sorry, this one, right, which is 0.5785. Okay, so can you help me? 0.5785 divided by 4, what is the value? Of dy?
0.1446.
Alright, thank you. Now, here is the importance of the 4 significant number. If you give me 1.14, right, I'm okay, alright, but don't expect your answer to be, your L to be the same as mine lah. Alright, there will be difference, expect difference. Okay, now, after that, okay, now let's look at the formula. Okay, let's look at this formula here. We need to determine which formula we want to use. Anyone have suggestion which formula I should use? For is it for all section, rectangular or very wide channel?
Very wide channel.
Rectangle.
This is not very wide channel, right? Because B is 5 meter. Okay, thank you. Rectangular. Okay, if you want to use all section, is fine. Okay, but it's going to involve more calculation, right? Because Q squared times T over G A cubic power, you are going to find the A few times, all right? Four times, so basically you have 4 parts, right? Now, since this is a rectangular channel, we are going to use the second set of equation, which is this guy here. I'm going to write it down. Just reduce this first. So we are going to use this formula here. We have here this value already. We also have this value already. Okay, the power is 3, the power is 2, okay, now I'm going to reduce this. Okay, let's get back to this. Okay, now we have dy, we have x naught. What else do we need to find? Y average would depends on the you know, we need to find all this y first, right? For another, you know, another 3 y's. So we'll solve this later. We can actually solve for YC first and K naught first. K average will depends on Y average as well. So this is available. Okay, so we need to find YC right now. Okay, somebody is joining. This. Okay. All right. Now, anyone can help me find YC? Now, I don't mind if you straight away want to use, you know, Q, you know, capital Q, or you can separately calculate for your Q. It doesn't matter, right? Let's see. Okay, sorry. Anyone can help me solve this charge over unit width? Thank you. Mai satu ke? Okay, thank you.
Welcome, Doctor.
Alright. Okay, so I have discharge over unit width 2.548 meter cube over second over meter. Therefore, I can solve for my YC Q squared over G to the power of 1/3. I have 2.548 square 9.81 to the power of 1/3. Help me please, and everyone.
0.8508.
0.8
508.
betul eh? Oh, okay. I,
0.8771.
Sorry,
yes, yes.
Doktor.
Tak apa, tak apa. Don't worry, at least you have helped me. Thank you, guys. You have helped me a lot, okay? Because I can check also, okay? Is it correct, guys?
Yes, Doctor.
Yes,
Okay,
Doktor.
great. Thank you, thank you. Someone, I think, okay, internet problem, You are on, off. Okay, now, so I have YC already. Now, K naught. Alright, the next step will be to find K naught. K naught would be Q over S naught to the power of half, which is 12.74 divided by 0.001 to the power of half. This will give me
402.87.
402.87. Saya letak 9 pun boleh lah. Okay, because this is 4 significant number already, right? Okay, so I have 402.9. Anyone know the unit? This has no unit, right? S naught has no unit, right? So the unit is actually equal to discharge, Okay. Alright. Okay. So it doesn't matter if you don't write the unit, but I just want you to know, alright, the unit is actually equal to discharge lah, because it's actually conveyance. Alright, so we have there all this value already, okay? Now, after that, let's build, alright? Let me tentatively put into this, into 4 parts, Okay. So I have, I need to find, let's say this is Y1, Y2, Y3, Y4, and my Y5 is actually my YP, alright? Okay. So, okay, now, here's the thing to help us, right? We need, okay, to find K average, but before we find K average, we need to find Y average. Now, how are we going to find Y average for this? Let's tabulate all the data, alright, to help us. So we are going to tabulate this data, alright. So I'm going to have, alright, my Y in meter. Now, I'm going to have 1, 2, 3, 4. Okay, so this is we are focusing now on the method of numerical integration. So my y is, okay, if I look at here, my y is between 1.45 and now let us solve this first. What would be my y2? Anyone can help me? Y2 is dy is this one here, right? So y2 would be this minus this, right?
Yes, Doctor.
Dapat berapa? I just tentatively put here first, 1.3054. Agree?
Yes, Doktor.
Yes, Doctor.
Okay, great. So this, if you got this correct, you can use this to minus this. If not, you can use 1.45 minus 2 times this, because this is the second one, right? So it doesn't matter which formula you are going to use, you are going to get the same value, which it should be 1.1608. All right. Now, in my case, right, I'm going to use 4 decimal point. I'll let you know why, okay? Because this guy here, all right, it end up with 4 decimal point or 4 significant number, all right? Okay, this is 4 significant numbers. So I just keep, remaining the 4 decimal point there. So this will give me, sorry, this y, is actually this y, this y here, all right? Will give me 1.0161. Now, again, if this guy you minus 0. dy, which is 0.1446, right? You'll get back this value. Okay, this is cross-check. All right, you should get back the value. All right, so once you have that, I'm going to double it into a table here. So I have 1.45. You can actually calculate from this point upwards. It doesn't matter, right? Here to here or here to here. It's just that you probably would end up with negative if you are calculating from here to here. All right, let's check. You have to know the length of the gradually varied flow profile is a scalar, all right? That means there's no negative value. Length is positive. It's always positive, right? Well, if you talk about acceleration velocity, you have negative, right? When there's a deceleration, then it's negative, right? Now, okay, 1.45 to 1.30454. Then it's actually from this portion here, okay, is 1.3054 to 1.1608. Then I have the next part is all right. So far, okay, guys? So far, so good?
Yes, sir.
Okay, great. Okay, next step. Find y average. This plus this divided by 2, or this plus this divided by 2. So, I'm just going to write here. You help me check, okay? You in the meantime, you can help me calculate whether it's correct or not. Okay, then once you have that, okay, what else you want to find? Remember that our formula here, right? Okay, we have this. Now we have y average already, okay, for all this section, okay? Then K naught we already have, all right? So the next one we need to find K average. Now, what is the formula for K average? Should be, where is the formula just now? Is this guy here, all right? So it depends on our y average as well. So now, I don't mind if you can calculate K average directly. It doesn't matter, all right? If for me, I'll give you full mark if your K average is correct. But if you want to do step by step, okay, you can also find A average first, okay? Now, A average, meter square. A average should be B times Y average, okay? B is constant, right, which is 5 meter, right? So, 5 times Y average, you are going to get A average. So, now help me check, okay? I am going to have this value here, all right, with me. So my A average should be okay. You guys get the same answer? Or you can just check one. Did you get the same answer? That means 5
Yes,
times this. Okay, great. Okay, so the next one would be P average, which is meter. Okay, so this would be B plus 2Y average. This is the formula of rectangular. Okay, if it's trapezoidal, then you have to use, in order for you to find A and P, you have to use the rectangular formula. Alright? Sorry, trapezoidal, if it's trapezoidal. This is the formula for rectangular. Okay, so P average should be 5 plus 2 times this guy here. So just help me check the first value, right? For the purpose of, you try to do it as well. I'm not sure whether my formula is correct or not. If you are able to help me check all, is good too. Okay. Alright. So these are my values. Alright. Now the next thing is we can already find our K average, which is this guy here. Now, K average should be, okay, what's the formula? The formula would be, just how we have we have already have it, 1 over n, okay, A to the power of 5 over 3, A average, divided by P average to the power of 2/3, okay. What you can do normally when you key in the calculator, right, you have A average to the power of 5 over 3 divided by n divided by P average to the power of 2/3. Okay, you can lose the 1 here. It's basically I can have A to the power of 5 over 3 divided by n P to the power of 2/3. Okay, all right. So help me check. Okay, I'm not sure whether this is correct or not. I'm just I'm going to put the value here. Okay, now, can I ask anyone to check for me? Did you get 5,747.6? N is 0.017, Dapat tak? A average is this, P average is this. Anyone?
Saya tak dapat, Doktor.
Tak what value did you get?
6364.
Oh,
0.55.
okay. Let me check, okay? Oh, I think I know. Look at this. My formula is wrong. 374, betul?
Betul, Doktor.
Okay, thank you. Right. See, I told you. Okay. Sometimes I do have mistake. That is why I need you to help me, alright? So this should be, okay. This should be 374.4, 319.2, 266.2, and 215.7. Okay, so I guess let's just look at the Excel now, alright? So now this should be this lah, 374.4, 319.2, 266.2, 215.7. Dapat 374.4 kan semua?
Dapat.
Okay, dapat okay, now kalau dah dapat, alright, thank you. Once you have it right, now the next step would be you already have all this value. So to make life easier, you can actually calculate straight away. Calculate lah. It doesn't matter. You can calculate for dx. Alright. Or if you want to make sure, alright, you don't have any mistake, you are going to find this guy first. I don't mind if you want to skip, you straight away get dx, it doesn't matter. If you want to skip these two columns, it doesn't matter. Or you can you calculate yc over y average to the power of 3, and then the next step will be you calculate 1 k naught over k average square. Okay, now I don't mind. Okay, you want to skip, but if you want to do it step by step, so just calculate this. Later on, okay, we are going to have the last column, which is I'm going to continue here. The last column, which should be, alright, which should be dx, alright, in meter. This dx here, I'm going to have dy divided by x naught times this value divided by this value. I'll get this. Okay, so that will be my last column. So when I add this up together, alright, when I add this up together, I'm going to have L here. Alright, this value is the summation. That means L will be the summation of all dx lah. Alright, summation of all dx will give me L. Alright, so now let's solve this guy here first. Okay, now the first one would be, I'm going to solve it using Excel. It's easier, right? So I'm going to increase this a bit so you guys can have a look at it. Okay, now I'm going to have I didn't put the power there. It should be to the power of 3. So I have 1 minus. Okay, I have yc is what is our yc is 0.8715, alright, divided by my y average is this guy here to the power of, okay, 3. There would be slight difference between your answer and my answer, because I guess you are using 4 decimal point, right? But in Excel, right, it have, up to higher decimal point, right? So this would be my value. Help me check. Okay, so I have another one, which is k naught divided by k average to the power of square. This would be 1 minus, okay, k naught is 402.9 divided by k average square. Okay, don't worry about the negative. I told you, if you start from yc, if you start from yb, you probably won't get negative. Why negative? Because your depth of flow is decreasing. That's why. Alright. Oh, you actually start from downstream to upstream lah. Okay. So can you check for me whether this value is correct?
Yes, Doctor.
Correct, okay. This should be to the power of 3 kan? Okay. How about this value? Is it correct?
Yes.
Okay, great. Therefore, okay, dx would be, okay, I have, if you look at the formula, right, if you have your formula with you, right? Okay, I have dy 0.1446 divided by s naught, which is 0.001. Okay, this is constant. times, okay, this guy here divided by this guy here. So easy, right? Okay, since you have already have the column there, okay, so I have here. So you are going to end up negative, I told you, but this negative is due to this guy here, the k here, all right? But it should be positive because it's a scalar value, okay? But if you want, just put it, remain it, don't worry, okay? When you write it or you label it, you are going to get positive. So what would be the L, all right? L would be all of this one here. This is the total. So this would be, you know, your L. So let's draw this out, okay? So let me have this out first. So I'm going to have this. Okay, now, okay, let's go back, all right, to our table. This value is from the Excel, basically, Okay, now, so this is our value. Now, we are going to draw, to sketch it. You look at the question, right? It says, now we have solved it. This will be the length. We have solved the first part of the question for activity 4.8 here. So the next part of the question, it says label the depth and distance for each step. So I'm going to redraw this. Okay. Let's look at this. Okay. Oh, I have the paper here. Okay. Now, you see between, this is our earlier sketch, right? Okay. You see between 1.45, right, and 1.305, the distance is 600, almost 700. Between this and this, which is the second part, it's just 100, almost 157, like 158, right? So this distance is smaller. How about this? This is, you know, one third of this, right? Almost one third, right? And this is, you know, less than that. It's just very small, okay? So I'm going to draw this out. I'm going to have, okay, let's put this easier, okay. So I'm going to compare next to next, right? So I'm going to label the dead end. So I have 1.45 meter. This is the depth, okay. Next one, okay, because it's 600, right? Okay, so let's just put somewhere here. Because this is 683.7 meter. Okay, this is 1.3054 meter. Now it's just sketch, alright? Don't worry about it. It's not to scale, So I have here 1.0161 meter and 0.8715 meter. So this difference would be 157.73 meter, and then I'm going to have 54.52 meter, so I'm going to have 12.36 meter. Okay, so that's it. That will be the answer. Guys, are you clear so far? This is what I want. Hello, hi guys, are you still there?
Ada tak?
Okay, ada ya. So far jelas macam mana nak selesaikan ini? Mudah saja kan? Now, let me tell you, right, some of the mistakes, right, that students tend to make is, right, when they label out, right, they label here, they put here 683, they put here, 157, that means they do it, starting from here when they label it. You have to be careful, you have to refer to your why. It's actually when you get 683.7 is for this section here, which is between 1.54 to 1.3, which is this one here. So the dx would be this guy here. Now let's look at our formula, right? Now our formula here, it says dx, alright, of this part, alright, of that part, which is, we have already calculated all this, right? Alright, okay, and we plug in, so we actually get our dx to be 683.7. Okay, now do you have questions so far for this topic? If you don't have any question, I'm going to end the class right after this. All right? Anyone?
Doktor,
Ya, saya Maizatul.
yang dekat yang dekat Y tu, memang doktor
Yeah.
tulis tolak ke? Memang tolak.
No. Actually, which Y? Here.
Y
This.
bukan. Yang mula-mula sekali. Kotak yang mula-mula.
Yang dekat mana?
Yang kita nak cari Y average tu.
Oh, sini
Sebelah tu.
No. This is not minus, sorry. This should be 1.45 to 1.3.
Okay.
Actually it's between. I just put this dash, this lah. It's not minus, it's dash lah basically.
Okay, doktor.
It's between, okay, because we want to take the average, okay. Okay. Okay, any other question? If no question, I'll see you guys on Monday, next Monday, alright? Okay? Guys, I'll see you guys on next Monday, alright?
Alright, doktor.
Okay, take care, bye-bye.
Thank you,
Bye.
Thank you, Doctor.
You're welcome. Alright.
Thank you, doktor.
You're welcome.
Doktor, saya nak tanya sikit
Yes, boleh. Siapa yang Mimi okay.
Untuk projek,
Yes.
kan untuk kira peak flow tu kan, Q sama dengan CIA per 360 tu kan. Untuk kira I tu nak guna formula yang mana ya?
I tu nak guna formula apa? Sekejap. Saya tunjukkan.
Okay, doktor.
You tak jumpa formula dia?
Sebab kita orang confused banyak sangat. Kalau kita orang cari kat Masmo tu ada yang guna formula ni. Lepas tu kita orang cari kat internet pun ada guna formula ni. So kita orang
guna, actually kan, it's good if you just use the notes that I've given you. Semua dekat sana. Jangan risau. Kadang-kadang, yelah, untuk maklumat tambahan, yes, we actually find it from the internet. But it's best if you look at, from Masma itself. Okay, now let's look at Masma. Ada tak jumpa formula I equals to lambda t to the power of kappa divided by theta plus d? Pernah tak jumpa formula tu?
ada doktor.
Then actually all those constant, right? That means you have lambda, kappa, theta. There's another constant. I forgot which one constant. It comes from the appendix. Okay, now let's look at the whole screen. I'm going to present whole screen right now. Present share screen. Okay. Entire screen. Okay, dah nampak Masma kan?
Nampak doktor?
Okay, nampak So kita nak pergi cari intensity Alright. Okay, rasa bukan nak keyword lah. Alright. Let's see. Okay, I found it already. Empirical. Okay, the keyword will be empirical. So, now, this is the formula. Equation 2.2. You need to use this formula now. Where does you are looking at my formula right now, right? On the Masma one, right? I equals to lambda t kappa divided by d plus theta to the power of eta. Alright, Okay, now you have here, alright, I would be the average rainfall intensity T. Okay, now here, remember this T here is, I think the question already give you ARI. Agree or not? Ada tak dalam soalan bagi ARI?
Ada.
Yes, doktor ada.
Okay. Dia bagi berapa ARI dalam soalan projek?
20 tahun.
20. So, you are going to use 20 year. Now, later I'm going to show you why there are two sets. Okay, now, storm duration, okay, between 0.033 hours and 32 hours. May I know 0.0833 hours is how many minutes? Anyone? Hello? 0.0833 jam tu berapa minit?
5 minit ke tu?
5 minit betul. Okay, minimum 5 minit Now this will be your time concentration. Okay, now tahu tak D itu sama dengan TC? Tak tahu Tahu Sebab if you go to check kat sini ada satu section tu it describe on TC, time of concentration. Actually there's a statement that say you need to use time of concentration duration equal to TC or greater. It says that. So we can use D equals to TC lah basically and minimum of TC will be 5 minutes. The same topic under time of concentration, it actually says minimum 5 minutes to adopt minimum 5 minutes. Now, lambda, kappa, theta, and eta are fitting constant depending on ring gauge location. Now, let's go to appendix 2B. So, I'm going to have, I'm going to find, okay? Fitting constant, okay. Okay, here, appendix 2.5, 2.B, alright? Now, look at this. It says ARI 2 and 100 year. So you have this fitting constant, lambda, kappa, theta, and eta. Now, there's another fitting constant. Okay, if you drag this down, okay. If I go down, okay, what else? Okay, if I go down, all right. Here, it gives you fitting constant for ring gauge or station name. Okay, I believe I give you, what is the location that I give you in the project?
Kampung Sungai Yap.
Kampung Sungai Yap.
Okay, Kampung Sungai Yap, negeri mana?
Pahang.
Faham.
Okay, alright. So, Kampung Sungai Yap. So, you are going to use this 65, 9, all this four, okay? So, you have that. Now, here, you are using 20-year ARI, right? Don't read this table, There's another set of table, okay? After this, you see? This is another set. Just how 2B1 or I'm not sure. Is it 2B1? Okay. Okay, this is table 2.B1. Okay. Another set is table 2.B2. This is ARI for low ARI between 0.5 and 12 months. Just now is 2 to 100 years, right? So there's another set for Pahang, Kampung, Sungai Yap. See, there's different, right, in your coefficient. So be careful, choose the right set. Okay. Clear on that, guys?
Clear, Doktor.
Okay. Jadi ada apa soalan lagi?
Tak ada, Doktor.
Tak ada, Okay. Kita jumpa next Monday dah.
Doktor, saya ada soalan.
Okay, boleh, Mak Zata?
Kan nak cari D daripada TC sama dengan TO tambah TD kan?
Betul?
T0 tambah TD.
Mhm.
Untuk cari T0 dengan TD ada slope. Macam mana nak dapatkan slope tu?
ada tengok video project tak?
Yang kedua tu ke?
Yang kedua.
Ada?
Ada. Tak boleh faham Mak Zata?
Yes, betul. Saya pun tanya soalan tu juga.
Oh, macam tu juga. Okay. Saya explain kat sini Okay. Kejap turn off camera. No. Present now. Entire screen. Okay, sekarang dah nampak blank piece of paper kan?
Nampak?
Okay, now. Saya ambil contoh bench drain Saya ambil contoh bench drain. Okay. Saya kata ada kawasan ni, maknanya ini ID. So kawasan yang akan mengalir masuk bench drain ni, is it anyone has problem in understanding me explaining in BM? You may speak now. Okay, kalau tidak saya cakap BM Okay. Now, kawasan yang akan diairi oleh BC1, okay, or drainage area ialah kawasan ni lah kan. Sebab kawasan hulu atas ni semua akan masuk dekat longkang ID lah, interceptor drain. So yang akan masuk dekat bench drain ni, okay, ialah kawasan ni saja. Dan ini ialah cutting slope kalau ada yang tak faham, intercept saya. Okay. So saya bagi contoh ni sebab mudah Okay. Now bench drain. Sekarang ni saya nak cari TC. Saya tak tahu sekarang ni nak tentukan slope BC ni. Okay. Ingat tak dekat plan yang saya bagi tu, setiap 25 meter saya bagi keratan cross section, betul tak?
Betul, Doktor.
Okay, contohnya kita tengok projek kita cross section. Oops. Saya bagi contoh je lah Saya ambil je mana-mana keratan. Okay, contohnya. Tengok saya ambil contoh 400 meter chainage. Ini ialah lokasi satu bench drain. Sebab kalau tengok, sini ialah jalan kita, ini ialah cut area yang akan dipotong. Okay. Ini ialah slope of cutting. Okay. Ini lokasi satu bench drain. Sebab kalau tengok aksi Y ni, okay, dia dah 6 meter ni, antara sini dengan sini 6 meter akan ada satu bench drain. Lepas tu ada cut slope lagi kat atas ni ialah interceptor drain. So ini ialah lokasi bench drain, interceptor drain dan juga roadside drain. Okay. Sini menjelaskan existing elevation ni ialah elevation yang ini tau. You guys nampak tak cursor yang tengah bergerak ni?
Nampak dia.
Nampak tak?
Nampak Nampak kan?
Nampak Doktor.
Okay, nampak. Okay. Ini ialah yang existing level. Kemudian ini ialah finish level. Finish level yang ialah platform yang you nak bina lah ni. So, kalau tengok ini ialah elevation platform level ni. Kalau tengok di sini kan, finish level ni kan, ini ialah elevation 74.922. Actually menunjukkan ketinggian sini tau, bench drain ni. Okay. Now, offset pula ialah dekat tengah-tengah jalan ni kosong. Ke sebelah kiri negatif, ke sebelah kanan ialah positif. Okay. Maknanya tengah jalan tu kosong lah median center line dia. Okay, now kalau saya bandingkan challenge 400 dengan 425, okay, untuk bench drain, boleh tak saya tahu alirannya mengalir daripada challenge 400 ke 425 ke daripada 425 ke 400?
400 ke 425.
Kalau bandingkan. Okay. Sebab, kenapa?
400 lagi tinggi
Kenapa?
pada 425.
Okay. Itu cara nak menentukan slope antara 400 ke 425. Tetapi, you have to be careful tau. Contohnya, kalau saya tengok plan long ni, kalau saya besarkan kan, actually kan, yang ini ni nampak tak ada dua garis yang selari ni kan? Ini ialah kedudukan bench drain pertama dan ini ialah kedudukan bench drain kedua. Sebab bila saya cut, exactly saya akan dapat balik yang ini. Contohnya 400 kan di sini. Ni 400. Perasan tak? Sini ada satu bench drain, sini interceptor, sini tak ada bench drain. Kalau tengok balik yang 400 tu, dah tak ada bench drain. Okay, so itu kedudukan bench drain lah dekat sini. Now, apa yang kita kena buat sebenarnya, kita kena tentukan arah tau aliran ni. Daripada, kalau tengok satu bench drain ni, maknanya daripada 325, 350, 375, 400, kita kena tengok semua ni. Sebab kemungkinan, okay, kemungkinan saya tunjuk balik sini, kemungkinan akan ada, okay, arah, kalau saya tunjuk yang sepatutnya saya lukis, dia mungkin macam tu, saya tak tahu. Ini contoh, okay, kemungkinan dia bukan mengalir semua ke sana. Kemungkinan, ini bagi contoh sebab saya tak letak change mana-mana. Kemungkinan dia akan split, arah dia mengalir. Jadi setiap cross section ni kena bandingkan. Tapi jangan compare dengan drain yang tak sepatutnya. Tadi kita compare bench drain dengan bench drain. Kalau nak compare interceptor dengan interceptor lah okay. Nah, ini pun saya tak pasti macam mana dia mengalir. Mungkin dia akan mengalir macam tu. Mungkinlah. Saya tak pasti. Okay. Jadi, you kena semaklah setiap cross section ni gradient. Now, once you dah tentukan arah, contohnya macam ni kan. Saya kata, saya nak design drain, the whole drain ni lah. Okay. Tapi saya nak cari Q. Okay. Nak cari Q, kemungkinan, okay. Kalau saya nak design Q, of course, satu longkang ni, kita lazimnya kita guna standard size longkang. Tak mungkinlah sini kecil, lepas tu kita sambung dengan satu size yang besar kan. Kalau kawasan ni Q lagi besar daripada sini. Jadi, saya nak cari konsep time of concentration ni, saya rasa you all dah tahu kalau saya plot hydrograph kan, Q melawan masa. Saya akan dapat pada time of concentration ni, iaitu for all the discharge to concentrate at the outlet kan. Katakan ini titik paling rendah, ini outletnya. Ialah time needed TC time needed. Ialah masa yang diperlukan. Kadang-kadang ini dalam BM kita panggil masa penumpuan. Semua aliran, okay, aliran permukaan tertumpu di outlet, okay. Jadi masa yang diperlukan untuk semua aliran tertumpu bila hujan tak berhenti, maknanya hujan berterusan, Q dia akan constant sebab semua dah contribute. Maknanya, kalaulah dekat titik sini, bila hujan, kawasan ni akan mengalir ke sini. Kawasan ni belum sampai kat sini. Jadi kawasan ni mungkin baru mengalir sampai sini. Tapi kalau dah titik tambah concentration ni, kawasan hujan yang turun dekat kawasan ni pun dah keluar kat sini. Kalau hujan tak berhenti, pastilah akan malah je kan sebab memang semua dah mengalir keluar kat sini. Nah, kalaulah saya tanya you all kan, kenapa kita nak kira kat outlet kat sini? Kita tengok yang aliran yang nak masuk kawasan hulu longkang ni kan, ialah kawasan ni je. Sebab aliran ni kawasan ni tak mungkin mengalir naik atas. Kawasan ni semua akhirnya akan tertumpu di sini. Okey, bila saya cakap kawasan tu maksudnya aliran lah dekat kawasan ni semua akan tertumpu kat sini. Jadi betul tak kalau saya cakap Q yang paling tinggi pada mana-mana titik ialah titik yang dekat outlet ni? Betul tak?
Betul.
Jadi kita tak mungkinlah nak design ni pandangan atas drain kita macam ni. Ni pandangan atas tak mungkinlah lebar drain kita ataupun kedalaman drain kita daripada terbalik okey. Terbalik drain kita macam ni. Dekat outlet ni besar, lepas tu makin kecil. Jarang kan kita nampak size drain yang macam tu kan. Ini pandangan atas Jadi lazimnya kita berdasarkan Q maksimum ni kita design standard je. Jadi Q mana yang kita nak ambil ialah Q sini. Now, nak tentukan TC ni ialah berdasarkan masa yang paling lama tau untuk aliran keluar. Saya rasa dalam MASWA dia ada cakap juga time of concentration, you have to consider the time of flow from the furthest point right to the outlet. Now, kenapa ialah masa itulah yang semua aliran akan tertumpu di outlet. Nah, kita tengok untuk kawasan ni sahaja. Sebab kawasan ni akan masuk sini, kawasan ni akan masuk sini. Sebab untuk cerun potong kan, cerun dia seragam je kan, turun ke bawah kan. Jadi aliran dia patut turun ke bawah seragam je lah. Nah, sebenarnya masa aliran ni ada banyak kombinasi. Mungkin aliran ni bila hujan turun dekat titik dekat atas ni, dia perlukan masa mengalir atas permukaan rumput kan. Sebab kita dah potong, kita akan tanam buat tefing kan rumput. Masuk dekat longkang, dia mengalir keluar. Kemungkinan alirannya dia mengalir macam ni. Saya tak tahu, tapi disebabkan cerun dia seragam, aliran dia akan mengalir turun lah kan, betul tak? So, kita ada kombinasi mengalir ke sini, tapi kalau ikut kita punya rasional, masa yang paling lama ialah titik ni, sebab titik ni paling jauh kan, dia nak masuk dan longkang dan mengalir ke sini. Kalau kita tengok kombinasi ni pula ialah sebenarnya masa yang untuk dia mengalir daripada sini ke sini dan masuk longkang dan mengalir kat sini ialah lebih pendek lah. Jadi untuk tujuan itu kita akan ambil masa yang paling lama sebab bila kita consider masa yang paling lama, kita tahu semua aliran ni dah sampai pun dekat outlet. Okey, kita tengok sini ialah T0. Masa yang diambil untuk mengalir pada cerun potong ni. Okey, overland, iaitu atas permukaan, overland Lepas tu, sini ialah masa yang diambil untuk mengalir dalam saluran, iaitu TD. Okey, tadi siapa yang tanya saya soalan yang Maizatul kan? Okey, Maizatul saya nak tanya, slope drain ni boleh cari tak?
Tak boleh.
Kenapa pula? Tadi kan
Boleh,
baru
Doktor.
tengok slope. Tadi kan drain ni, Maizatul kan dah tunjukkan dia kata dia mengalir ke sini, dah ada difference kan? Kita pergi balik contohnya lah kan, katakan saya nak ambil, saya nak ambil dua slope ni. Saya nak tahu kecerunan antara 400 dengan 425. saya kata beza dia 74.922 tolak 74.829 bahagi 25 meter. Boleh tak saya dapat cerun dia?
Boleh.
Itu saya bandingkan antara dua keratan. Jadi kalau patutnya mungkin you consider antara kalau you tahu arah aliran dia, contohnya lah kita pergi balik, contohnya kita tahu keratan ni semua arah aliran dia sama, kita boleh dapatkan cerunnya antara chainage contohnya 400 dengan 450 ke dan seterusnya lah. Tadi saya hanya bandingkan chainage yang berikutnya saja. Tapi kalau nak dapatkan slope yang lebih baik, you boleh bandingkan. Tapi kan nasihat saya mungkin boleh juga difikirkan buat Excel ataupun jadual lah you boleh masukkan. Sebabnya kan cerun ni tak seragam tau antara satu keratan dengan satu keratan. Jadi kita boleh plot kan. Contohnya kan kita kata kita boleh buat antara chainage 400, contohnya chainage 400, 425. Okey. Ni kan saya pergi balik sini. Okey. Saya kata ini bench drain punya elevation. Saya kata bench drain ni sebenarnya kan saya boleh letak subscript 1 tau untuk bench drain pertama kalau ada banyak bench drain kan. So elevation dia berapa, lepas tu saya boleh plot graph daripada data ni. Saya boleh plot graph contohnya chainage 400, 425, 450. Mungkin saya dapat titik yang tadi kata mengalir ke mana sini. Okey, contohnya lah. Okey. Dia mungkin dapat yang tak seragam cerun dia, tapi kita boleh andaikan satu cerun yang seragam. Itu kalau you nak buat analisis yang lebih terperinci lah. Sebab masa yang sebenar dekat site pun you kena pastikan ada aliran berlaku, takkan tersangkut sebagai engineer. You kena pastikan. Jadi you kena modify jugalah sikit. Okay. Nah, clear slope drain ni setakat ni slope drain ni clear Mai satu dan yang lain?
Clear, Doktor.
Okay, clear.
Doktor.
Slope tu
Oh, ada
LD
lagi kes.
distance L ni dapat boleh kira kan? Jarak kan nak cari TD perlukan slope dan juga jarak kan? Jarak LD ni. Boleh Maknanya tengok dekat contohnya kat sini 25 meter campur 25 meter 50 meter lah kan? Betul?
Betul.
Okay. Tapi kalau you boleh tambah sikit pun baguslah. Sebenarnya kita bila tengok pandangan atas dia berbeza tau dengan yang sebenar. Contohnya kat sini kan. You tengok pandangan atas jarak ni je tau. Betul? Kalau you tengok dari atas kan ni mata kan. Pandangan atas sebenarnya yang sebenar dia mungkin lebih panjang. Betul kan?
Betul. Jadinya kita kena tambah sikit.
Kalau you nak ataupun dalam report you boleh cakap limitation ataupun had ataupun scope yang you guna. You kata mungkin you tambah berapa persen, tak kisahlah, you tak tambah pun tak apa, tapi cakaplah panjang tu berdasarkan pandangan dari atas, things like that. Sebenarnya okay, tak apa, saya nak cerita tentang slope. So far okay LD ni boleh So dah once you dapat LD, you dah dapat S0 untuk cari TD ni, you dah boleh cari TD. Sekarang kita tengok T0 pula. Okay, T0 ni, okay, you pun perlukan S0 dia ataupun SF lah. You pun perlukan L0 dia. L0 dia, okay, I boleh cari L0 ni. I boleh tengok dekat pandangan plan ataupun kalau cross section tadi, kalau lah yang L0 yang nak masuk ni kan, chainage 400 ni kan, boleh tak saya dapatkan jarak ni? Sebab jarak di mana run off mengalir ialah menerusi tebing ni kan, kecerunan ni kan. Betul tak guys?
Betul doktor.
Betul. Okey. Saya sebenarnya boleh dapat jarak ni kalau saya tengok, you tengok jarak ni ialah beza ni kuasa 2 campur beza ni kuasa 2, punca kuasa 2, saya boleh dapat jarak ni kan? Betul? Ingat tak formula ni? Sekejap. Sebenarnya slope cutting tu you dah tahu kot slope-nya berapa. You boleh ambil slope dia lah. Kalau saya tengok balik kat sini. Ini slope dia berapa? 1/berapa berapa ni slope dia? Guys? Tak ada suara Ni 1/2 kan? Betul tak? Guys? You guys tak dengar saya
Dengar doktor.
Dengar.
Okay.
Dengar.
Maksud saya ialah okay. Itu kan 1/2 kan? Betul? Sebenarnya kalau saya nak cari jarak ni kan, yang di mana kalau hujan turun dia mengalir kan, masuk dekat drain ni kan, ni ialah bench drain kan, betul kan? Betul tak? Saya tunjuk macam ni lah. Okay, saya tunjuk macam ni. Kita nak cari jarak ni kan? Okay. Kalau nak cari jarak ni, okay, saya sebenarnya ni sebenarnya slope potong 1/2. Okay. Sebab kalau you tengok dekat sini, okay, you tengok sini lebih kurang 10 meter. Ketinggian ni lebih kurang 5 meter. Okay, dia sebenarnya lebih kurang slope 1/2. Jadi, kalau saya nak cari panjang ni, okay, saya sebenarnya kalau kat sini ni saya tahu ini 6 meter. Jadi, sini ialah 12 meter. Ini untuk cari panjang untuk masuk roadside drain. Untuk masuk sini pula, saya buat anggaran Saya buat anggaran sini lebih kurang 4 meter. Okay. Saya kata sini lebih kurang 4 meter. Sini pula kalau situ 4 meter, kalau you tengok slope dia yang itu biasanya ialah sini 8 meter lah. Okay, kalau saya nak cari jarak ni bukan ke bukan formula ni ke kita pernah belajar? Nak cari LD. Kan? Ingat tak?
Betul.
Guys?
Betul.
Betul? Okay. Kan you all dah lupa? Okay, tak apa. Okay. You guys tak ada respon pun Okay, now. Once you ada itu, jadi now, once you have this kan, nak cari nak cari slope. Slope ni, you dah ada jarak. Slope-nya ialah ini je lah. 1/2. That's it. Betul tak? Mas satu ke siapa?
Betul,
Itu slope-nya. Okay. Okay, itu satu. Macam mana you nak cari slope interceptor drain ni? Okay, atas ni. Interceptor drain ni, kalau you tengok, okay. You tengok kita kena buat anggaran apa kecurunan kan, sebab untuk interceptor drain ni kita kena tentukan juga L0 ataupun S0 kan, kecurunan dia. Jadi saya buat anggaran contohnya ini 82, 83. So ini titik ni kemungkinan sebab dia meningkat kan. So titik ni ialah 84. So saya boleh ambil 85, titik paling tinggi, saya tolak, ataupun saya boleh ambil 2 titik 83, 84.2 tolak 83.25 bahagi dengan jarak. Jarak ufuk lah. Jadi beza ketinggian bahagi jarak ufuk, saya dapat kecurunan kan untuk topografi ni kan, betul tak? Untuk bukit ni.
Betul.
So itu cara dia You kena buat anggaran, tapi of course dekat pengiraan you kena tunjukkan lah. Alright, data apa yang you tolak, data apa bahagi dengan jarak berapa, things like that. Okay, boleh guys? Boleh tak? Faham tak? Siapa yang tanya saya tadi? Main satu ke Pak Suntra ke? Do you guys understand right?
Doktor, kira kita kena cari setiap challenge lah dia punya slope semua tu.
Bukan kalau yang daripada bukit tu you boleh buat anggaran lah. Tapi yang dekat slope dalam drain tu, kalau you pertimbangkan 2-3 challenge pun okey, tak payah nak plot semua. Tapi saya bagi tahu kalau betul-betul buat design, bila you dah keluar engineer, you kena pertimbangkan setiap section. Cuma untuk case project kita, saya mudahkan. Tapi you kena tunjukkanlah pengiraan you. Boleh tak, Syafiqah?
Okey doktor.
Okey. Boleh?
Doktor,
Ya saya, Yuslan.
nak tanya kan doktor cakap dalam video kat YouTube tu,
Ya.
ada certain tempat tu dia ada TC, ada certain tempat tu dia ada TD. Apa maksud doktor?
Okey. Apa maksud saya contohnya Okey, contohnya. Okey. Katakan saya nak cari satu ini satu kawasan. Saya sepatutnya kawasan yang saya draw ni lebih kurang macam ni lah, tapi saya nak terangkan apa bezanya. Dia ada, tapi betul buku bumi ni dia macam ni tau.
Doktor tak present.
Sorry, saya tak
Okay.
present. Nasib baik. Thank you inform. Dah nampak bagi tahu
Alright, nampak.
Okey, dah nampak Okey. Contohnya lah kebetulan kawasan ni topografi dia tau. Sini titik paling tinggi. Okay. Longkang saya kat sini, ini drain saya. Saya kata ini ialah drain je lah. Saya kata drain. Okey. So boleh imagine ini kawasan paling tinggi kan? Ini drain saya. Lepas tu kecurunan drain saya macam ni tau. Boleh
Boleh doktor.
Okey. Jadi bila hujan turun, arah aliran saya macam ni kan, betul?
Betul.
Betul doktor.
So dalam kes yang ini, kombinasi, saya nak cari TC ni. Rasa-rasa you all lah. Saya cakap ini ialah pathway pertama, iaitu ini tak ada TD. Ini hanya T dot saja dia keluar dekat outlet. Ini outlet. Outlet. Okey. Pathway kedua, dia nak mengalir ke sini tak mungkin sebab cerun dia macam ni kan. So, ini hanya ada, mungkin ada sikit yang masuk sini, dia ada sikit T naught tambah TD. Okey, ini pathway pertama. Okey, ini pathway kedua. Ada satu lagi pathway, ini dah mengalir tempat lain lah, assuming saya nak consider outlet sini Ini, okey. So, antara pathway pertama dan pathway kedua, rasa-rasa you all, yang mana masa yang paling lama saya nak cari TC?
Pathway pertama.
Kalaulah ini, sebab mengalir atas aliran ni, dia tak selaju mengalir dalam drain kan? Kalau katakan drain ni pun dia punya kecurunan tinggi kan? So, saya boleh consider pathway pertama. Pathway kedua ialah T naught plus TD. Okay. So, perasan tak? Akan ada case yang macam ni. Dan ada juga case yang TC sama TD saja. Boleh Itu maksud saya. Maknanya you tak nak consider pun T naught. Contohnya saya nak design drain ni. Kemudian drain ni lepas tu kemudian mungkin topografi dia semua aliran mengalir ke sana. Drain ni purpose-nya untuk ambil drain daripada atas contohnya lah. So kemungkinan tak akan ada T naught. Mungkin hanya akan TD sahaja. Boleh tak you guys? Guys, faham tak?
So doktor, yang T0 tu based on dia punya cross section lah doktor?
Bukan based on construction. This is plan view. Ini ialah overland flow time, betul tak? Time yang mengalir atas permukaan tanah. Yang ini ialah masa yang diambil mengalir dalam drain. Saya nak cari TC sebab TC ialah masa yang diperlukan untuk semua, bila aliran atas permukaan ni semua akan tertumpu dekat outlet. Jadi masa yang paling lama, alright, yang paling lama diambil ialah bila titik ni mengalir keluar ke sini berbanding, sebabnya bila saya consider bila masa ini mengalir ke sini, sebabnya aliran kat sini semua dah keluar ke sini. Kalau kita secara rasional kita fikir yang ini semua aliran ni dah keluar ke sini. Tak pun, you boleh tunjukkan T0 ni, you boleh tunjukkan T0 plus TD ni, you bandingkan, you ambil yang paling banyak. Sebab tujuannya kita kata at the end sebenarnya kita nak kata pada masa TC ni kan, semua aliran dekat kawasan ni dah keluar ke outlet, iaitu semua aliran tertumpu di sini. Jadi sebenarnya ada beberapa configuration lah. Kita boleh dapatkan yang ini, kita boleh dapatkan yang ini sebab aliran dia kan mungkin dia dah mengalir, dia masuk sini, dia keluar ke sini, dia mengalir, dia masuk sini, dia keluar ke sini, dia mengalir, masuk sini, dia keluar ke sini. Nampak tak dia punya pathway? Kan? Ini pathway dia kan? Mungkin ada drain kat sini lagi lah, dia masuk sini, dia masuk sini.
Pathway tu kira kita buat sendiri ke? Kita anggap
you kena imagine sendirilah. Sebab nak kata imagine, bukan, bila kita imagine, of course berdasarkan gradient kawasan ni juga kan, betul tak? Kan dia ada data-data gradient kan, kecurunan kan di kawasan ni. Jadi kita kena imagine bila hujan turun, sebenarnya alirannya mengalir macam mana? Kalau gradient dia macam ni, mestilah macam ni, tak mungkin aliran dia mengalir macam ni kan, betul tak?
Okey, betul. So, setiap pathway yang kita buat tu, kita kira, jadi kita ambil yang paling tinggi, dia punya...
yang paling lama. Sebab bila you dah consider yang paling lama, yang pasti semua dah keluar, betul tak? Kawasan-kawasan ni, aliran dia, Q dia semua dah keluar.
Oh, okey.
Betul tak?
Betul.
Okay. You boleh imagine kan bila hujan turun kat kawasan ni semua kan. Kalau dekat hujan turun kat titik ni, mungkin dalam beberapa minit air dah keluar. Kat sini perlukan aliran dekat kawasan ni baru sampai sini dia belum keluar. So masa untuk kawasan ni mengalir lebih lama daripada kawasan ni. Jadi saya sebenarnya nak cari untuk kawasan ni masa untuk bila masa semua aliran ataupun semua air hujan yang turun dalam kawasan ni mengalir keluar ke titik ni. Masa yang paling lama tu ialah bila tadi you cakap konfigurasi pertama tu ialah bila aliran ni mengalir keluar ke sini. Bila kita pertimbangkan masa tu sebenarnya kita kata aliran kat sini dah keluar pun kat sini kan. Dan bila hujan tak berhenti, berterusanlah dia akan keluar. Campur dengan aliran dah ke atas ni dah sampai sini, betul tak Q dia akan malar kemudian?
Betul.
Okey. Itulah maksud saya.
Jadi untuk kes macam ni kita consider T0 dia lah.
Kalau lah betul, T0 ni paling lama. Daripada contohnya satu lagi yang kata T0 plus TD.
Tengok kita punya drawing tu, maksudnya kebanyakannya T0 je lah yang paling tinggi.
Drawing you tadi ada je yang T0 plus TD ni masuk sini. Sebab ini kan, ini slope potong, tak mungkin dia mengalir macam ni. Baru saya cerita tadi kan.
Nampak.
Okey. Jadi you kena tengok kecerunan kawasannya tu. Boleh
Boleh doktor.
Okay. Buat dulu. you guys kalau boleh tunjukkan apa yang you dah buat tu senang saya nak explain. Okay? Boleh you guys?
Doktor,
Yeah, Indrajit.
I want to ask a final question here, sir.
Okay.
For the doctor, for T naught and TD, the value for slope is same or different, doctor? Different, right?
lah.
Different, right? Okay, okay,
Different.
that's all.
Okay. So, okay, I'll see you guys next Monday.
Doktor,
Yeah, Syahidah Zul. Syahidah tahu ada soalan ke?
saya nak tanya yang T tadi.
Yeah.
Untuk yang kira D tu macam mana?
D sama dengan TD. Sorry, D sama dengan TC.
Bukan. Yang I tadi. Yang formula I. I. Untuk D tu dia macam mana?
Okay, kejap saya tunjukkan sekarang ni masih present whole screen ke? Belum kan? Okay.
Belum.
Okay. Okay, bagi daya pas. Okay. Okay, tengok chapter time of concentration dia cakap mana ni? Dia bagi tahu TC. Okay, nampak tak ni last line ni? The practice is to select a design storm duration as equal to or greater than the time of concentration. Design storm duration mana I tadi? Ni storm duration kan? Betul tak?
Betul.
Jadi D sama dengan TC. Boleh? Tapi kena tahu TC ni, minimum TC ialah 5 minit. Okay. Boleh?
Okey, boleh doktor.
Okay. Okay? Lagi ada soalan lagi?
Doktor.
Syafiqah.
Sekejap. Untuk average run-off coefficient, dia ada dua develop dengan undeveloped. Ke macam mana?
You nak cari average run-off coefficient, tapi I think dalam case you senang je kan? Okay, sekarang kita tengok Masma. Kita tengok Masma. Saya tak present lagi
Belum doktor.
Okay. Alright. You nak cari C yang dekat rational method kan? Betul tak? Ni kan jadual dia kan? Betul tak? Jadual ni yang digunakan round coefficient kan?
Ha?
Ha?
Tak, macam saya tengok ada yang contoh report tu, dia kira dia ambil macam area dia ada develop dengan undeveloped, lepas tu run off coefficient pun dia ada develop dengan undeveloped. Macam confused kat situ. Kita orang nak ambil area
saya
yang mana?
tahu macam ni. Okay, konsep dia kan, kenapa you nak kira dua kali? Dia macam ni tau. Dia satu, kenapa dia kira undeveloped tu? Satu, dia nak sediakan temporary drainage. Bila you buat construction kan, you nak sediakan temporary drainage. Lepas tu, bila you final punya drain, ialah you kena kira kawasan develop. Logically, develop punya Q lagi tinggi, betul tak? Sebab you akan banyak kawasan yang berturap kan, betul?
Betul.
Jadi logically kawasan terturap. Biasanya you sediakan temporary drainage tu waktu-waktu macam you nak pastikan you know you punya bila hujan turun kawasan you yang you dah clear tu dia punya flow, mud flow dan sebagainya, sediment flow semua tak akan masuk kawasan orang lain, you akan sediakan temporary drainage. Betul tak? Jadi yang itu you akan kira undeveloped. Tapi dalam kes projek ni, you all tak payah kira pun undeveloped punya coefficient. You guys hanya kira yang developed saja. Boleh tak?
Boleh doktor.
Okay, boleh doktor.
Alright.
Terima kasih.
Sama-sama.
Doktor.
Ya saya.
Itu nak kira macam mana?
Jap, saya tak dengar sangat. Boleh kuat sikit tak?
TC tu nak kira macam mana?
T apa?
TC.
TC?
Doktor kata D sama dengan TC kan?
TC tadi formulanya T0 plus TD plus TG. Itu formulanya kan?
Okay, terima kasih doktor.
Sama-sama. Okey, lagi? Okey, kalau dah tak ada, kita jumpa Isnin Boleh?
Boleh doktor. Terima kasih doktor.
Terima kasih doktor.
Sama-sama.
Terima kasih doktor.
Okay. Alright.
Thank you doktor.
Halawati nanti tanya kawan mungkin Halawati tak dengar sangat apa yang saya explain tadi tentang PC.
Doktor, video ni nanti doktor akan upload kat YouTube kan?
Ya, saya akan upload. Ya.
Okay, thank you.
Thank you doktor.
Alright.
Doctor,
Yes, tiba sini.
are you free now because we are planning to present you our calculation for what we have done so far?
Okay, sure. Actually, could you present it? I can only give you a few minutes because I don't want to check your calculation. I'm supposed to evaluate your report, right? Not by checking it. I'll just go through the steps only. Is that okay?
Okay.
Okay.
Yeah.
So I'm going to stop recording this first.
Okay, doctor.
Okay.